This is the Eiffel Tower located in Paris, and this is its miniature placed on a shelf. You must have also seen small toy cars that look exactly like the real ones. We can say that they look similar, right? They have the same form or shape but different size. Can you recall when was the last time you saw these words together, shape and size? It was when we learnt about congruent figures. Congruent figures are those figures that have the same shape and same size. For example, two circles are congruent if they have same radius because then they have the same shape and same size. And if placed on top of each other, they overlap completely. In geometry, the figures which have same shape but different size are called similar figures. Let's take example of circle again. If we have two circles, one of 2 centimeter radius and let's say another one of 4 centimeter radius, they are clearly different in size, but they have the same shape. They are round. But still, how do we understand this term same shape? What does it mean exactly? When we say that two figures have the same shape, we mean they look alike in terms of structure, and one can be made to fit perfectly over the other by resizing or scaling, but not stretching or bending. Let's resize the circle to half. Once we do that, we see that these two overlap. We can take any two circles with any radius, and if we resize them, they would overlap. If we stretch them, it would become an oval. That's a completely different shape, right? But zooming in or out doesn't change the shape. So we can say that all circles are similar. Let us take example of another elementary shape, which is square. We have a square of side 2 centimeter, another one of 4 centimeter. Now, if we scale this down and place on top of each other, they would overlap. The angles in the square are same. They're all 90 degrees. All squares are also similar. Because think about it. If you have, no matter, you have any square of whatever length, you can resize them and they would overlap on top of each other. So, one thing is sure that shape is somewhere determined by the angles, right? Now, if we look at rectangles, we have two rectangles, one of 4 by 2, another one of 8 by 2. Rectangles again have same angles, they're all 90-degree angles. But if I resize this one and try to place it on top of the first one, they are not overlapping. On the other hand, if we had a rectangle of 8 by 4 and we resize it, now it is overlapping. So we see that the shape or similarity has something to do with sides too. We realize that there are two conditions for similarity. One, that the corresponding angles should be same. Because if we change the angle, the shape gets distorted. It's a different shape, right? Second, the corresponding sides of the two figures should be in same ratio. We also say that the corresponding sides should be in proportion. Let us take example of these triangles. Now, let us check if they are similar or not. First of all, we confirm with the angles. So, we have angle A which is equal to R, angle B which is equal to P, and angle C which is equal to Q. So, one condition is met. But for these triangles to be similar, both of these conditions should be met. So, now let's check for the second one. Are the sides in proportion or not? If we look at AB and PR, if we look at their ratio, AB is 2 and PR is 6. So, the ratio over here is 1 by 3. Next, if we look at BC upon PQ, BC is 4 and PQ is 12. Again, the ratio is 1 by 3. Then we have CA and RQ. It's 3 by 9. That is again 1 by 3. So, the ratio of all three sides is same. We can say that these sides are in proportion. So, now, yes, we have not taken these measurements, exact measurements, but just think about this. If we resize PQR to its 1/3 measurement, it would completely overlap with triangle ABC. So once on resizing or scaling up and down, the figures are overlapping, we can say that they have the same shape. And that is one important condition that should be met in order for the shapes to be similar. Similarity has many applications. How do we know the height of a huge tree or a mountain? How do we know the distance of faraway objects such as sun or the moon? Let us look at one example. Let's say we have a tree and we want to know its height. Now, we cannot just climb all trees and drop a measuring tape to measure the height, right? But let us imagine that it's a sunny day. In that case, it's the shadow of the tree would fall on the ground like this, right? Now, if you notice over here, this is kind of forming a triangle. And just imagine that you stand over here, you would also have a shadow, right? Now, the sun's ray hit both the tree and the girl at the same angle. So, this is also forming a triangle. These two triangles are actually similar. And since these two triangles are similar, their sides would be in proportion. We can measure the shadow of the girl and the tree. And we can find the ratio, which would be equal to the ratio of height of girl to height of tree. We know the height of the girl. If it's you, you know your height. And through that ratio and your height, you can easily find out the height of the tree.